Hello, hi everyone. Good afternoon. Welcome all. Let's begin. Alright, so who are here, who are present? You can type, comment in the chat so that I'll know. Hi Shrey, yes, it was late by a couple of minutes. Hi Joshua. Let's start, let's begin. So today we are going to learn about refraction by spherical lens. So we have learned what are the two types of lens, correct? Do you know? Okay, we'll learn them today, and then we are going to learn when the light falls on that lens, how it gets refracted. So by the way, my name is Dr. Akash and this is about me. So I have a PhD in physics from National University of Singapore, BSMS dual degree from ISA Pune, ranker in JEE Advanced and KPY. Alright, any questions, any doubts until now? Anyone? Or from the previous lecture? No questions? So what is a spherical lens? You see here, there are a lot of different types of spherical lens that we use. Even if you are using the specs, so there are spherical lens present. If you are using the telescope or microscope, then also they use the spherical lens. So they have a lot of different applications. Yes, so that is why it is very important for us to study them. So let's study them. So what are the different types of spherical lens? There can be a lot of different types depending on the shape. For example, here you see the two surfaces, they are outwards. So when the surface of the lens is outwards, then it is called as convex lens. If the surfaces are inwards, can you see here? So there is a concave lens, but not all the lenses will have both the surfaces either inwards or outwards. For example, this lens, one surface is like a planar surface. There is not a plane mirror, but there is a plane surface, right? So this lens is called as, there is a convex and plane. So there is like a convex, plano-convex lens. How about here? There is one surface which is plane, another surface which is concave. So this is called as plano-concave lens. But how do you determine whether the lens is a convex or concave? So there are certain rules. So we look at the edge. So if the thickness at the edge is smaller compared to the thickness at the center, then this lens is called as convex lens. They are thicker at the center and thinner at the edge. How about concave? Concave lenses, they are, sorry, this is a concave. Concave lenses, they are thinner at the center and thicker at the edge. So whenever you find a lens which is thin at the center, even this one, thin at the center compared to the edge. So this is a concave lens. Yes? Yeah, these are not mirrors, they are lens. We have learned the mirrors, now we are learning lens. Okay, now let's understand why these lenses, they are called as spherical. So what is special about them? You see, these are the two surfaces. Surface number, there is a surface number 1 and this one is a surface number 2. So this surface 1, this one, which is our surface 1, it is a part of this sphere. So there is a sphere number 1. I'll write here, there is a sphere 1. So there is an imaginary sphere. It is not physical sphere which is present, just that this edge, it is a part of this sphere. Okay. Similarly, this surface 2, it is a part of this sphere number 2, right? So here the sphere number 1, it will have some radius. So this is the radius of this curvature. Curvature meaning this curved surface. So curved surface means the curvature. So it is the radius of the curvature. Then here we have center. There is a C1 which is the center of this curvature. Similarly, here there is a center 2, C2, which is the center of curvature for the surface number 2, and there is R2, which is the radius of curvature for the surface number 2. Okay. All right. So now these are the important things which you know or you should know, but we are going to learn very easy or simpler case. We are going to learn biconvex lens. Biconvex lens. And what is the special about this? So what we are going to do, in general, the lens can have different radii of curvature, but we are going to choose R1 is equal to R2, which is simply R. So now this lens will look something like this. So there is a center of the lens which is called as optical center, this point here, which is exactly at the center, this O. So now here we have, this one was C1, this one was C2, right? But we are not going to use this terminology of C1 and C2. We are going to use a new terminology. So for this lens, this is convex lens, which is also called as converging lens. I'll show you after some time why it is converging lens, but there is a point in between O and C1. So this point is called as F1. Correct? We are only worried about this F1. So once we get F1, so we know this length is going to be equal to the focal length. If this is focal length, we go equal distance. So we'll come to this point, which is 2 times F1. This 2 times F1. So we are going to use this terminology. So in that case, when R1 is equal to R2, if the both radii of curvature they are equal, then this C1 will be equal to 2 times F1. If they are not equal, if the radii of curvature they are not equal, so this 2F1 may not be same as C1. C1 might be some different point and 2F1 might be some different point. Okay, sorry, this we are going to call this as F2. Here we have F1 and 2F1. So we are going to use this terminology. There is 2F1, F1, optical center, F2, 2F2. Similarly, for the concave lens, you see there is a concave lens. Again, it has 2 different curvature. Both of them are inwards. That is why it is called as, so this is a concave lens, because both the curvatures they are inwards. Now it has R1 and this R2. In general, R1 can be different from R2, but again we are going to use a special case, which is a biconcave lens. So in that, R1 is equal to R2 and just call it as R. Okay, again when we have this kind of lens, there is a concave lens and here there is an optical center. Again you will find the focus, which is F1, there is 2F1, there is F2 and 2F2. So we are going to follow this convention. We are not going to write C1 or C2. In mirrors, we write C1 and C2 because there is only single center. But in lens, because we have 2 curvature, we are not going to write C1 or C2. We are only going to write F1 or F2. Clear? So this is about the structure of the spherical lens. Now, this is a terminology. Just now I have said this is F1, F2. This will be the focal length from optical center to F2. Now if you go another distance F, then we'll come to this point, which is 2 times F2. There is F2, this would be 2 times F2. So when C2 is equal to 2F2, only when, so C2 will be equal to 2F2 only if R1 is equal to R2. That means only if this is a biconvex lens or biconcave lens. Similarly, we have 2f1 here, f1, f2, 2, f2. So these are the terms you need to know. Now, once you understand this terminology, नोट्स कहां से मिलेंगे? एट द एंड मैं आपको बताऊंगा, एक टेलीग्राम चैनल है, उस चैनल में आप सब्सक्राइब कर लो, हर एक क्लास के जो नोट्स हैं उस चैनल में आ जाएंगे और बहुत सारे एमसीक्यूज या फिर प्रीवियस ईयर क्वेश्चंस, बोर्ड क्वेश्चंस, वो सब उस चैनल में आपको मिल जाएंगे, है ना. एट द एंड ऑफ द क्लास आई विल लेट यू नो द लिंक फॉर द टेलीग्राम चैनल. नाउ मैं थोड़ी देर पहले आपको बोला था कि हाउ टू फाइंड द फोकल लेंथ. तो अभी चलो देखते हैं फोकल लेंथ कैसे निकालनी है इसकी. So here these are the incident rays. Can you see all of these are the incident rays? They fall onto this biconvex lens. Now after refraction they meet at a single point. You see this point? All these incident rays, they meet at a single point which we call it as a principal focus. So पिछले वाले स्लाइड में आपने देखा था, वहां पे मैंने f1 f2 लिखा था, it is that focus. Now similarly in the concave lens these incident rays, they diverge, they go away from each other and they appear to come out from a single point. So that point is called as focus. So when you have convex lens, focus is on the right, there is a right side, so this will be the focal length. So focal length is measured on the right side of the optical center, but when we have a concave lens, there is an optical center, the focal length is measured on the left. So this is measured on the left, this would be the focal length for the concave lens. Clear? Now there are certain rules for refraction. So whenever rays they fall onto the lens, there are few rules which you need to know, and once you know those rules, you can do all the type of ray diagrams, you can draw all the type of ray diagrams. And from where did we get these rules? Okay, we are going to learn the image formation in the next class. I'll tell you, there are few rules, but what is the origin of these rules? So I'll quickly tell you. Let's suppose this is a concave surface, you know, there is a concave surface, this is high refractive index. For example, this is a glass, there is a glass and this is air. So refractive index here is 1, refractive index for example here is 1.5, and let's suppose for this curvature we have the center here, this is like a center of curvature. Okay, so if there are certain incident rays, for example these are the incident rays, so what will happen? These incident rays, they are falling on the concave, there is a concave surface, this surface is concave surface. So at all these points you can draw the normal. So there is a center, from the center you can draw, this is the normal, correct? Again here you can draw a normal, right? So now when you draw the normal, okay, I'll only take the two rays which are quite far away. Now the rays going from, there is a low refractive index, from a region of low refractive index to the high refractive index. So when the light passes from low refractive index to the high refractive index, what happens? The rays bend towards the normal. So in this case the refracted ray, so this is the refracted ray, it is going to bend towards the normal. Similarly here this is also going to bend towards the normal. Can you see? They are bending towards the normal. So whenever rays they bend towards the normal, that is a concave surface, and that is the reason they appear to diverge. If you retrace them backwards, they will appear to come out from this point. This would be the focus, है ना? So when you have a concave surface, this is like a diverging surface. How about convex? Let's suppose you have a convex surface and this is the center of curvature. Now let's suppose these are the incident rays falling onto the convex surface. At these surfaces you can draw the normal. So this is a point of incident and the center of curvature. You can connect these, you'll get the normal. Again similarly you can connect this. So this is the normal. Can you see? Now what will happen? This is the direction of the incident ray. It is going from air to glass. When the light goes from air to glass, that means low refractive index to high refractive index. There is a low refractive index to the high refractive index. What will happen? It will bend again towards the normal. This dotted line, these are normals. So what will happen? क्या होगा यहाँ पे? Light कैसे bend होगी? Towards. Can you see? It is bending towards the normal. ये इसका incident light है. There is an incident, right? So this was the path. It bent towards the normal. तो ये दोनों क्या होंगे? Somewhere here they are going to meet. So this will be the focus. समझ में आ रहा है अभी आपको? So whenever you have a convex surface, this will act like a converging surface. When you have a concave surface, this is a diverging surface. Concave meaning diverging. Diverging surface. And when you have this convex surface, यहाँ पे मैं लिखता हूँ, this is a convex surface. Convex surface. So this is a converging surface. Clear? So that is why the convex lens they are called as converging lens and concave lens they are called as diverging lens. Clear? So now let's understand some rules. So you need to know only about these three rays. When these rays they pass through the lens, how they behave. Once you know these, you can do all the ray diagrams. You can draw all the different ray diagrams for these lenses. Okay? Now first is a convex lens. Look at here. This is an incident ray, a ray which is parallel to the principal axis. So the incident ray parallel to the principal axis. After refraction, what will happen? It will pass through a single point, and we know that this point is called as focus. So when the incident ray is parallel to the principal axis, after refraction it passes through the focus on the other side of the lens. There is a focus on the other side. There is a side of the object. There is a side of the object, and that is the other side of the lens. Clear? So this is the first rule. Now if you want to draw the proper ray diagram, you need to mention this. You need to write all these. Then only you will get the correct mark. You have to write to F1, F1, F2 to F2, all of them. Now the second rule, जब भी the ray is passing through optical center, तो जब ray optical center से होके pass करता है, then what happens? See here. So this is the incident ray passing through the optical center. तो क्या होगा? It passes without any deviation. इसको कोई डिस्टर्ब नहीं करता. वो जिस डायरेक्शन में जा रहा है उसी डायरेक्शन में लेंस के बाहर आ जाएगा, है ना? That is the best ray. So this ray, whenever it passes through the optical center, it passes without any deviation, इसको कोई disturbance नहीं है, it just pass without any deviation. So that is our rule number 2. Now let's go to the rule number 3. So when the ray is passing through the focus, there is an incident ray passing through the focus. So this focus is on the same side. So here we have, let's suppose, object. So the focus is on the same side as the object. So what happens to this ray? So when this ray fall onto the convex lens, it passes parallel to the principal axis. ये अपना principal axis, right? This is a principal axis. So there is a refracted ray. So refracted ray is a parallel to the principal axis. This is the rule number 3. So ray passing through the focus goes parallel to the principal axis after refraction. So there is a ray diagram you need to remember. So learnt these 3 rays. Tell me, what are those? First ray, when the ray is parallel to the principal axis, passes through the focus on the other side. Ray passing through the optical center, pass without any deviation. And third one, ray passing through the focus will be parallel to the principal axis after refraction. Now let's learn about concave lens. Here we have a concave lens. Again the same 3 rules or same 3 rays. First ray, incident ray parallel to the principal axis. They all diverge and they appear to diverge from a point which we call it as focus. So this is a focus on the same side. So there is an object. So there is a focus on the same side as the object. So ray parallel to the principal axis, incident rays, these are, and this is a refracted ray, appears to diverge from the focus on the same side. This focus is on the same side as the object. Clear? Now there is a ray diagram. You write F1 and F2. Now when you have the ray directed towards the focus, you see this focus? The focus is on the other side. So for example, object is somewhere here, there is an object. So the ray will be directed towards the focus, something like this. There is an incident ray. Can you see? There is an incident ray which is directed towards the focus. So when it falls onto the concave lens, the refracted ray will be parallel. So whenever incident ray is directed to the focus on the other side, there is a side of the object, that is the other side. When the ray is directed towards the focus on the other side, what will happen? The refracted rays go parallel to the principal axis. So there is the incident ray and the refracted ray. And the third rule, which is the easiest one, ray passing through the optical center. So there is an incident ray passing through the optical center. It goes without any deviation. So there is no deviation to this ray. Okay, goes without any deviation. So that is the rule number 3. Incident ray passing through the optical center without any deviation. So these are some of the rules which you should know. And somebody was asking me, there is a Telegram channel link. Go to this link, subscribe to the channel, you will get all the updates, all the notes. There are a lot of MCQ questions, lot of previous year questions, lot of other content is present on this Telegram channel. So do subscribe to the Telegram channel. If you have doubts, you can ask there and let me know. Alright, so that's it for today. Bye bye everyone.